What if your main gateway fails right now? Your entire network goes down. Even if you have a backup router, most devices can only use one default gateway. But what if I told you there's a way to make your network bulletproof? Discover how HSRP creates a virtual gateway that never fails. Plus, a secret trick to double your bandwidth. Want zero downtime? Let's dive in. In this course, we'll look at different protocols used to do gateway redundancy. On this topology, we have a PC connected to a switch. This switch is connected to two routers that both have an IP address that could be used as the default gateway for the PC. And behind our two routers, we have the internet service provider. In this case, which default gateway should we configure for the PC? Router 1 or 2? Knowing that you can only configure one gateway. If, for example, you choose router 1 and it fails, then the PC will no longer be able to leave its own subnet, and so he will no longer be able to go on the internet. The solution to this problem is to create a virtual gateway between router 1 and router 2. This virtual gateway will have its own IP address. On our topology, we assign it 192.168.3. This is the IP which our PC will use as the default gateway. One of the two routers will be active, and if it is unavailable, the second will take over. And this is transparent to the user. There are three different protocols that can be used to create a virtual gateway: HSRP, VRRP, and GLBP. So these three protocols all work in the same way. There are only a few small differences on the commands to type. We will start by looking at the configuration of HSRP, which is a Cisco proprietary protocol. But first of all, we're going to configure all the IPs on our topology. We assign the IP 192.168.0.1 to the 00 interface of router 1 and the 0.2 on the 000 leg of router 2. Then, we will configure the links that go up to the router of the access provider. We put the IP 192.168.10 on the FASO1 interface of router 1 and the 20.1 on the 01 of router 2, and we still have to configure the router's IPs at the top. 10.2 for the 00 interface, and 20.2 for the 01. If you reproduce this topology on Packet Tracer, you will need to create a Loopback interface to simulate your internet router, because a Loopback will always respond to a ping. Here it is assigned the IP 1.1.1.1. So in the current state, routers 1 and 2 have no knowledge of the Loopback network. That's why we're going to create a static route to it. On router 1, it is told that to join the Loopback network, you have to go to the interface that carries the IP 192.168. 10.2, i.e., the Fast Ethernet 00 interface. And we do the same for router 2. Now we can start configuring our HSRP. To do this, you just have to connect to the interfaces of the router that carries the gateways and do a standby IP plus the IP of the virtual gateway. In the example, we chose 192.168.0.3. The small 1 after the word standby corresponds to the HSRP group, and that's all there is to it. From this point on, one of the routers becomes active and the other remains on standby until the active drops. For example, if router 1 has become the active one, and after having successfully configured the virtual gateway on the PC, ping the loopback address from the PC, will go through router 1. And if router 1 falls, then the failover will be done automatically, and without modifying the gateway on the PC, the packets will go through router 2. Now, Let's go into a little more detail. Here, our active router is 2, and router 1 is in standby mode, and we configured HSRP on both routers. We will now analyze the ARP table of router 2 by doing an ARP IP show. Here we can see our virtual address, the 192.168.3, which is associated with a MAC address, which is also virtual. HSRP uses the MAC address 4 zeros. 0cu77.ac plus the HSRP group. No, in our example, we had set up group 1. There is a very interesting command, which allows you to check your HSRP configuration. It's the order show standby. We can see the virtual IP address, virtual MAC address, and which router is active or in standby mode. The active router will respond to the PC's ARP requests and transmit its packets correctly. It will also send hello messages to the router that is asleep. As for the latter, it will just listen to the hello messages of the active router. If the router is out of sleep receiving messages, hello every 3 seconds, then it will become the active after 10 seconds. By default, the switch with the highest tau priority will become the active HSRP device. And if the priority is the same, the selection of the asset will be done by NZ, the highest IP address. Since the priority of both routers is set to 100, which is the default priority, then the active router will be the one with the highest IP address. This is router 2. And finally, if we want router 1 to become active, we just have to set it to a higher priority with the standby priority command.